Okay, for our first experiment today, we're going to experiment with Boyle's law. And Boyle's law basically says that at a constant temperature, which is this room at this point, and this water, and there's an eyedropper with water inside it and some air inside it, that at constant temperature, an increase in pressure is inversely proportional to the volume of the air of the gas. So the air is the gas. Right now, the pressure is atmospheric pressure in the room. And so it has this much volume. And for this experiment, what this basically does is this eyedropper has enough water in it so that it's just barely able to float. See that? It just barely comes to the surface. So what we're going to do is we're going to put this lid on top of this peanut butter jar. Really, really tight. And the peanut butter jar isn't the best. A 2-liter bottle would be better. But this is what I had, and I'm going to try to rotate it around, which you can't do because of inertia. So now what I'm going to do is I'm going to squeeze the bottle. And when I squeeze the bottle, what you're going to see is the line of the air or the water is going to go up because I'm going to increase the pressure inside, which is going to force water up inside, which will decrease the volume of the air inside the eyedropper. And as it decreases, there won't be enough air in there to keep it buoyant. So I'm going to squeeze. You can see that thing go up, and then it falls to the bottom. And then if I let the pressure off, the water comes back out of the tube, and then the eyedropper can float again.
Is that it for this one?
Okay, so I'm going to try this same experiment with this glass bottle because it's just nostalgic for me because I remember this experiment from when I was your age, and I got myself a glass bottle, and I'd had this experiment set up for like a week, and I kept doing it. So the best thing to use is like a wine bottle with a cork. But because all of our stuff, all the science stuff is still at Evergreen, we don't have access to that, so I found this little plunger thing that will do kind of the same thing. So I'm going to force that down, and then it's going to go diving. See him down there?
Just putting the lid on increased the pressure then.
Yeah.
Whereas with the peanut butter bottle, it didn't.
Okay. So again, I'm just taking this and I'm just pushing this much air. You have to keep the bottle pretty full, but if you push it down, it's enough to force that up, and it goes up into the thing. So our cork is really cool because you can adjust it and you can play with it and try to get it to sit like halfway. Definitely something fun to do.
Well, if you have a cork and a wine bottle, you can try this at home, and an eyedropper.
An eyedropper. There you go.
That's almost, yeah, it's about halfway.
Okay, for our second law today, we're going to experiment with Charles's law, which has to do with temperature. So if you have a constant volume and you either increase the pressure or decrease the pressure, it will change the volume inside the container. So in this case, we have a glass container, we have a balloon, and this.
You said pressure, did you mean temperature?
I don't know. Pressure. Let's see. So the pressure will increase with increased temperature, and it will decrease with decreased temperature.
Okay.
Meaning the volume of the gas will shrink because it'll want to get closer together, has less energy in it if it gets cold.
Yeah.
And if it gets warm, that means it's running around faster and it has more energy and it expands.
Okay, so you have hot water in one and cold.
So we have a pan of hot water here and a pan of ice water here. One very important note: you do not want to go from one extreme to another. You always want to go back to room temperature before you do this because there's a lot of stress built up in this glass already, and the thermal expansion between one to another extreme can cause the glass to break. So don't do that. So
why is the balloon puffed up already?
just because when I put it on, I pulled it down.
Oh, okay.
So we can let
It caught some air.
Yeah.
Okay.
Okay. So we'll do this experiment with a time lapse, but because it takes a little while to do that, but you can already see it shrinking.
So this is cold, so the gas is shrinking and the molecules are getting closer together.
Right. So decreased volume, decreased temperature. Now we're going to go back to room temperature. And this isn't real hot. It's been sitting out for a while. It was boiling at one point, but it's been sitting down here on the shelf. But it'll start to expand again.
Might want to talk a little louder.
Okay. And then if you put it in the warm bath, and again, this isn't very warm, but
Oh, I
you
can
see it start to
yeah.
expand.
Hmm.
And that's Charles's law.
Cool. All right, I just wanted to tell you guys a few last things about your homework. This message at the start is for Form 3B. Your note card activity is due today. That's 20 note cards, and I did put an assignment up for you to post it to. There's a couple of you whose emails or your mom's emails are not on there, so if that's you, just go ahead and paste it to the Form 3 stream. Copy it or paste it or whatever. For the rest of you, it's just going to be lessons, let's see, 25 through 27 for next week before spring break. There's a couple experiments that we'll try to post at the end of next week because I'm no longer going on my Utah trip. And they're actually pretty easy ones that you might try at home. If you have a ping pong ball, I think you need a ping pong ball and some rubber bands. We'll post it, but they look pretty quick and easy and you might want to try them at home yourself. Also for 3B, since this project 2 is due today, project 3 also starts, and project 3 is a oral presentation. So again, choose a physicist, maybe 3 sources. I don't want you to write the paper. I want you to practice giving a speech. You can write it out on some note cards, practice it at home. Hopefully it'll be due May 8th. So hopefully we'll be back together again by then. If not, I'll probably have you post them. But hopefully we'll be able to see each other after spring break. So have fun and enjoy spring break. Bye.